when we are coding, what's happened is we have something that we need to achieve. Okay, but for example, the first and foremost, the training that we will do is we will run the Hello World application. Okay, so the purpose of that application is basically to print Hello World in the console, or print Hello World somewhere as an alert box or UI or whatever. So by doing that, we are solving a problem. Okay, the world hardest problem, saying hello. So we are making sure that that is achieved. Okay, so given the complexity and everything, the printing hello world is like the smallest problem that we will ever encounter in programming. But when we have more complex ones, um, more more examples, more complex situations, like say for instance we need to create order in our we need to create an order in our e-commerce system. So will that will get a lot of complexity, and we need more of algorithms to do so. So the main problems of doing such a things when we are doing the programming stuff, the main advantage is that it is not the first time that we are doing this. E-commerce websites are already available out there, and people who want to send an email already have done that. And certain algorithms, they have been implemented so far. So in such a case, we do not need to reinvent the wheel, as we say. We do not need to reinvent the wheel. So we can leverage what we have right now, and we can reuse some of those components within our architecture, within our code base, and we can leverage and we can save our time. So the design patterns, they follow the same concepts. They have the same philosophy. So design patterns help us in a way that we do not need to reinvent the wheel. Okay, there are these patterns, what we call, is something what we call not invention, not something that we're gonna be creating from scratch, but something that we do like a discovery that is there, and we're gonna be using it. We're gonna be making that happen. So let's see what is like a perfect definition for a design pattern. I'm not sure whether you guys can see it, so I'll make it a little bit huge. So design patterns are typically solutions to common occurring problems in software design. They are like pre-made blueprints that you can customize to solve recurring design problem in your code, as it explains. So we have common occurring problems in when we are creating softwares. Okay, so one of the things that we have done so far is creating a new object. How do we create a new object? We can use an object that is by using the new keyword. Or we have seen some places where we use dependency injection. We use dependency injection to create our objects. We use IOCs or containers to have our objects created for us. So in different ways, we can achieve the same goals. Okay, so there are common problems that we have to come across each and every day when we are doing a project. So for example, the creation, and sometimes when when we do something in the code or something in the some operation, there should be an update in somewhere else. That kind of behavior operation is going to be there. So these problems are commonly occurring in each and every softwares that we are using. So by using a design pattern, what we can do is we can easily solve those things. Okay, but it is not something that we're going to build from scratch, but we are providing a solution that is based on a pre-made solution. Okay, so um, uh, so we will see what are these pre-made solutions, what are the blueprints that we can use, and what sort of things it can resolve. Okay. Um, um, so you can't just find a pattern and copy into the program. The way that we can functions or libraries, pattern specific piece of code, but in general concept of solving particular problem, you can follow the pattern details and implement solution that suits the realizes of your own program. So as it mentions, so it is not like a piece of code that we can copy and paste and it works. Okay, we have such scenarios where, for example, we want to fetch some information from internet. There we will find some piece of code. If you guys can remember, uh, we have used retrofit in our MVVM application to get some information from the internet and put it in our Android application. Okay, so they have a step-by-step guideline. Okay, you need to add this library, you need to call this function, you need to create this instant object, then you will reach your destination. Okay, so we got some code examples to do so, and what we can do is we can copy paste those codes and it works. Okay, but in a design pattern, that is not the case. In a design pattern, we can't just copy paste and make sure it is working, but it is showing us the way. Okay, if you want to achieve this, if you want to achieve this, achieve this state, what you have to do is uh, you need to follow these. You need to use this plan, and once you implement this plan, it doesn't structure how you're going to use it. Okay, it's not going to say, okay, you need to copy this one, you need to do next this step, you need to do this at next step. No, it's not going to tell us, instruct us how we're going to do it, but it's going to say, okay, this is the way that you need to do. The implementation is up to you. But in a sense, so design patterns are like more of a blueprint. They are not going to give you the whole solution like algorithm. It's going to be just like a blueprint. But to achieve these things, to achieve these kind of design patterns, okay, there can be libraries. There can be libraries which will help us to achieve these things. For example, if you guys can remember, when we are using the NT architecture application, we had used something called services in our Spring Boot application. So by nature, service is using a design pattern of their own, which we call a singleton. Okay, so that library under the hood, they are using something like that, but we do not need to know that it is still in use or still in implementation. What we need to do is we're going to be using a library like framework like Spring Boot, and it's going to help us through the journey, and they have implemented the design pattern. All we are doing is just using it, but under the hood the design patterns are in use, and we will be using those design patterns in order to improve our code. So otherwise what we have to do is, say for instance, in the world of Spring, if you want to, if you need to know, okay, we need to create a singleton, then you have to know everything, and that's kind of thing. So it's not gonna make things easy. So what we can do is, in this scenario, we do not need to know that that's certain implementation at that point. What we can do is we can simply utilize the underlying design pattern and work with it. Okay, so don't don't think that design patterns is like off-shelf solutions. These the concepts or the design pattern itself, they are not going to provide us with some sort of algorithms. Okay, do not get confused algorithms and design patterns. Okay, so the algorithms have a certain way of doing things. Okay, you first you do this, second you do this, third time you do this, and you get your result at the end. But in a pattern, you don't get that such of instruction. What we get in a pattern is that you will get the blueprint. Okay, this is how it should be implemented. The implementation, the steps that you are going to taking is up to you. Okay, so the perfect example in this in here for real world analogy is like algorithms are like cooking recipe. Okay, so both we have the clear step to achieve our goal. So in a cooking recipe, it says, okay, you need this amount of food, this amount of ingredients, and first thing you need to do is you need to mix these things. Second, you need to bake these things, and all the things are step by step broken down to you. So you have to follow the steps, and you will achieve the food recipe on your own. But on the other hand, patterns, they do not give, okay, this is like what you're gonna do. It's gonna be something like a blueprint. So if you have a problem, okay, the problem solution is something like this. Okay, so we have a blueprint. Okay, so you know, if you use this blueprint, if you use this plan, you can overcome your problem. You can find a solution. If you use this blueprint, you can overcome your solution. So that's the difference between an algorithm and a pattern. So in design patterns, you won't find any step-by-step solution. You will get the end result, but how you're going to do is the plan that you need, is the blueprint that you need will be there for you to help. So the algorithms and the patterns, design patterns, do not get confused, do not mix those things up. They have different purposes, but they achieve the same thing, finding a solution for our problem. Okay, so so in this in a design pattern, so what do we get out of a design pattern? So it's a blueprint. Okay, so what are the limitations of a implementation of a pattern? What sort of thing that we can what we can get out of a design pattern? Okay, the most of the time that we get is the intent. Okay, what is the purpose purpose of this pattern, and briefly describe what is the problem, and this is the solution. Okay, so in a design pattern, you will find, okay, we have this problem, so how to overcome this? You will use this. That's kind of the one of the traits, one of the things that you will get of a design pattern. So design pattern should have an intent. The motivation, further explain the problem and the solution. The pattern makes it possible. So motivation, why these kind of things were invented, and what's going to be the purpose. It's going to elaborate more. And the structure of the classes and each part of the pattern, and show how they are related. So the structure is like, okay, so in order to overcome this solution, in order to overcome the problem. Okay, this is the structure. This is how you should. This is how you should define this, and the basic structure of your implementation is given. Okay, so a design pattern is something like not bounded to any programming language or any framework in use. So design patterns gives you, okay, these things should be implemented, and if you implement it in your own way, you have to implement with the certain structure that we have given. So you follow this structure, you will get to the application, you will get to a goal. So and the next thing is a code example. Of course, when we are dealing with code example, when we are dealing with the application, we will probably get a code example explaining in Java, this is how you can do. In Kotlin, this is how you're going to do. Sorry. So if you are familiar with one language, and the other syntax are known to you, you can just do it yourself, or there will be plenty of code examples how you're going to do this in one or more language. Okay. And as I mentioned, the structure of doing this is going to vary from one programming language to other. Okay, some programming languages have some built-in features that will help the structure, the code example, very easy. Sometimes some programming languages do not have the structure, the facilities in order to make these things happen. So we need to make sure to use some maybe a third-party library, or sometimes we might need to use some different approach in other programming languages in order to achieve the same goal. Okay, the structure is there, the blueprint is there, the how you're going to make it, it's up to you. So the concept of blueprints, like if you take in the architectural terms or in a real world situation, so the blueprint, it's actually going to show something like let's say an architect is building a blueprint. So within the blueprint, they will show, okay, in here this is the living room, these are the bedrooms, and these are the washrooms and everything, and this is the garden. So they in here they have planned out everything where those things should be supposed to be. And implementation wise, okay, you have to think, okay, what are the materials that you're going to use? Oh, okay, to build up this wall, we will use cement blocks, or we will use wall bricks, or we will use these things. To finish up the floor, we will use tiles, or we're going to some polishing, or we're going to cut cement it. It's up to the person who is doing that. The implementation changes, but at the end, the goal is building a house. The building house is there. The design pattern describe, okay, this is the pattern. If you are building a house, these are the patterns that you should use. Okay. So there are like, if I'm not mistaken, there are like more than 20 design patterns available. So we won't be looking at each and every, but most common ones, most interesting one, we will look into those design patterns and see how those things will help us to become a better programmer. So the history, so history is like uh, how the design patterns came to existence. So I'm not going to go through the whole thing. It's basically, it is coming from the concepts of object-oriented programming and what are the things it has overcome. So there are like gang of four. So they they have given a lot of things in terms of design patterns. So you guys go through the history and take know what was the problem and why people invented these things in the first place. So there are like in most of the design patterns, came along to solve most of the problems with object-oriented programming, and they have evolved to other programming languages as well. So just go through these and you will get the history of it. So next thing is why we should learn these design patterns. What's the what is the purpose of it? So far, you guys might have uh, written some programs without even knowing any of these any of these patterns. Okay, so so far we have achieved we have created softwares without knowing anything about these design patterns, or without knowing a single thing about design patterns, but still work. It's and it is it is working, right? It's working. So what's can go wrong? So what's the motivation behind to learn these things now? So the first thing is industrial standardization. So most of you guys might know that um, might know, or knowingly or unknowingly, you guys might have used these design patterns uh, in your code. Maybe you guys have reinvented the wheel sometimes. Okay, without knowing, you guys have implemented one of these design patterns. Okay, but when you are representing this to a senior person, they might say, okay, you have used a factory pattern. Okay, that is good, but you did not know that such a thing, such a pattern was existing. You just did what you have to do, but end of the day, you have used something. But and when you are represented to someone else, they know the pattern, so they recognize that one. So in a sense, by using these uh, design patterns, so everybody in the rooms know, okay, we are talking about this certain architecture. Okay, we know, okay, so somebody is coming and saying, okay, first we will go through the application now. Okay, let's I think this application should be using singleton pattern. So you might be left out of, okay, if I don't know singleton pattern, then you'll be confused. Others know what singleton pattern is. If you do not know, then you will be left out of that. To avoid that, to standardize everything, so everyone in the same page, we use these design patterns to make sure that we are all in the same page. So sometimes other thing is that when we are using when we are trying to resolve a problem, okay, when we are trying to solve a problem, somebody or might already have done this. Okay, so how to create let's say e-commerce application, somebody might have already done that. Okay, so in a scenario like that, if somebody is already have completed the heavy task for us, all we have to do is, we do not need to rethink everything once again. All we have to do is, okay, if this person is done the job, what I have to do is, I need to make sure that I am using the same thing. That's it. So in a scenario like that, we will be reusing the code, knowingly or unknowingly. So we don't have to reinvent the wheel. It is already solved. We just use it once again, and it's working perfectly. So we don't waste our time finding out the same thing again and again. It's already been solved. So all we have to do is reuse. Okay, but the problem is with the design patterns, it does not resolve each and every programming problems that we have today, but at least most common ones are covered by these design patterns. Okay, so it's not going to solve the next problem that we are having in our architecture, no, but most of the common problems that we are having, so let's say we have a huge memory issue, that we are creating a lot of objects and we can't manage these things. What we can do, there can be a solution for that. Okay, but it's not going to say, okay, there is a huge problem in our servers, we are getting a lot of traffic and our servers are getting down. So there can be a solution within the design pattern itself. All you have to do is you have to learn these patterns and see how other people get rid of these kind of application, these kind of problems. Then you will get an idea. Okay, others use similar pattern like this and they were able to solve that, so we will be able to do the same thing. Okay, so that is the motivation. First one is the communication, everybody in the same page. The other one is we don't have to reinvent the wheel, we can utilize the existing things, so we don't waste our time. Yeah. uh, so there is like good and bad, right? Most of the thing, everything is coming with good and bad. The bad part is most of the time uh, patterns, these patterns are uh, giving a lot of troubles in some cases. Okay, so the problem in the most of the time that we are having is the knowledge gap. Okay, uh, and this will uh, this will this will hinder your knowledge on some things. So if the solution is already there, you don't have to think that much on the uh, uh, you don't have to think about the much of the solution yourself. It is there, so you have to use that. And sometimes the design patterns, as I mentioned earlier, um, uh, it does not have the capabilities within the programming language to do so. All right, especially with the strategy pattern that we'll be talking about, and simple anonymous lambdas. We'll just go through what are those things in later on. But for now, remember, some design patterns work on some programming language, but it is not working 100% on other programming languages. Some programming languages do not have the capabilities, or they do not have the functions that required to create such such patterns. Okay, so the other thing is the abstraction, and the abstraction will give you some saving of time. Yes, sometimes when we are using a design pattern, we will save a lot of time, but at the same time, the knowledge that we are gathering, that we are getting, implementing in ourselves, investing ourselves, it'll go away. And um, and the other thing is insufficient solutions. So pattern trying to systemize the approaches that we use, widely use. The insufficient view is maybe a dogma, and the implement patterns to the letter without adapting them to the context of the project. So the next thing that we will see is the adaptation will be something cumbersome for some projects. For example, we have some very advanced design patterns like facade pattern. So implementing a facade in our application, sometimes it is overwhelming for some projects. Some projects do not need this kind of this implementation, they can have a simple alternative, and the project will the people will not understand the concepts, and they find that is overkill of our software, and it might not suitable for your project. So that is that is gonna make the implementation little bit hard on the new people, especially the new people. They have to grasp a lot of knowledge, and sometimes they do not have the practice to grasp everything. So in a case like that, what will happen is you will probably lose the interest of the things that we are doing, and most probably it will not make use of the software that we are developing. It's not gonna make a day-to-day life of the developer easy. So we have to make sure the implementation is suitable within the organization, be it suitable within the project, and it is not overkill for our project. We need to make sure that it is used wisely. And the next thing that is like the mindset of the developer. This is something that I really see oftenly. So the thing is, when you have learned these patterns, let's say you have mastered all 23 to 26 design patterns, and what you're trying to do is you will sometimes some developers are boxed in within these patterns. Okay, so when you boxed in these patterns, you don't think out of the box. So if I get a problem next time, the next time that I'm trying to find is solution between those design patterns that I already have. I have 26 design patterns that I know. I'm trying to box in to the design patterns that I know. Okay. In a scenario like that, what will happen is we use the first one is we lose our creativity, and we will get frustrated which to use, and if it is not working as expected, then it is not gonna work. So learning design patterns, that is okay, that's something that we should have and we must as developers, but don't try to implement your hello world in a design pattern next time. Don't overkill it, or don't try to misuse it. Don't use it everywhere that you find. Okay, you will for simple for loop, and if the solution requires a simple for loop and you are trying to incorporate your learned knowledge or the design patterns into simple for loop, then you are misusing the design patterns. There are places where the design pattern shines, and there are places it does not make any sense. We have to make sure we are using the design patterns as intended, not overkill, not overuse it. Okay. All right. Design patterns based on what they're going to be doing, what are the solutions that we're going to do. They have been classified into several levels. Okay, design patterns differ by their complexity, level, details, and scale applicability, and entire system being designed. Like the analogy, road construction, you can make intersections safer by either installing some traffic lights or building an entire multi-level interchange with underground passage for the pedestrians. So in here, that means we have the implementation, we know the goal. It is up to us to make the solution build the solution based on what we know. Okay, we can have our solution built on top of one single pattern, or we can use another single pattern. So some are very easy to use, some are very complex to use. In this analogy that we are using, think a road construction. There can be two scenarios. There can be two ways that we can make an intersection where, okay, the people, there are like there can be crossings of either direction of the road. So what we can do is we can have installed traffic light, and one direction, when one direction flows, the other direction stops, and the flow works. The cost is less. And we can have another solution where all the interactions are multi-level. That means you have bridges on top of that, so you can have flyovers, you can have underground tunnels for passengers. So it's just the same thing, right? It helps with the crossing, but the problem is, what is the cost? The cost of doing such a thing will be variant. The complexity of building flyovers, underground tunnels, it is gonna be, by looking at it, we are not like the uh, road engineers or something like that, but by looking at the implementation itself, we can think, okay, that is a complex solution. We can't, it is not something like that we can put on a traffic light and do the thing. It's a complex solution, but it does the job. It is doing the job, and there are certain trade-off. Yes, if we install traffic light, there will be delays. If we have flyovers and underground passengers, then we don't have delays. But the complexity, the cost, all those things should be in mind in order to make these things. So based on these things, we have the classifications based on these complexities and based on what they are going to be doing. We have these classifications of these patterns. So the most basic low-level patterns are often called idioms, and they are usually applied on a single programming language. So the basic low-level patterns. So there are patterns where, like, very simple ones. You don't need that much of knowledge. So we call them as idioms, and especially it will have one single programming language that we can work with. The most universal and high-level patterns, like architectural patterns, developers can implement these patterns virtually in any language. Unlike other patterns, they can be used to design architecture of an entire application. Okay, so universal or high-level patterns, those are like architectural patterns. So anyone can use that. It's like most probably you can have these things in any language. So you are not vendor locked, or you are not programming language locked. These high-level patterns, anyone can use within any programming language. Okay, so there are certain complex ones which will be within a single programming language. Okay, so say for example, there is a design pattern that can be only achieved by Java. So there can be solutions where it happens, because the programming language itself have nice features. So using those features, we can have that. But as you guys know, some programming languages are like interceptors, intercepting, sometimes are compiled. So based on those things, there will be certain patterns which will be not suitable, or which will be not available on other languages. So that's kind of things be there. But these high levels or low level patterns are in use in our applications. So those are like the based on the complexity and the vendor of these things. In addition, the patterns can be categorized by their intent or the purpose. Okay. So this is like the most common way of categorizing design patterns. So if you go through any design pattern course, you will find this as the example of classification of our design patterns. So based on what we are trying to achieve, we will have our design patterns categorized into three main sectors. Okay, the first one is the creational patterns. Second one is the structural patterns. The third one is the behavior patterns. Okay, so let's see what sort of purpose or what sort of intents each and every one of these things have, and let's try to categorize well-known design patterns into one of these. Okay. All right. The first one is the creational patterns. Provides object creation mechanism that increases flexibility and reuse of existing code. So the creational patterns, as the name implies, it's help us with object creation mechanisms. Okay, so in order to create a new object, we can use these creational patterns. By using these creational patterns, we can easily create an object. Okay, so we have classes and we have implementations like objects. By using the class, how we can create objects? Of course, all of you might have used programming languages like Java. Within Java, you can always create a class, and to create an object, we use the new keyword and pass the arguments. We can have object creation mechanism, as we know. But that is not the only way. There are several ways that we can create, and each and every of these design patterns has its own pros and cons. We will see how we can create objects by using creational patterns, by using creational design patterns. The next thing is the structural patterns. Give me a second, guys. Okay, the second thing is the structural patterns. It's explained how we assemble of the objects and classes into a larger structure while keeping this structure flexible and efficient. As its name implies, how we can structure large objects, as you guys know. Um, so we have the most smallest form of classes. We say, for example, we need to make sure we include each and every section of our larger structure. Say, for example, we are trying to model a school. Okay, so our end goal is structure a school. Okay, so we need to create an object called school. But school is not just simple things. School can have a name, but school can have something like departments. Okay, so within the school, there will be departments. Okay, within the departments, you will find units, sometimes teaching units and all those things. So there will be units. And the unit can have students, lectures, and all those things. And you know, the list goes on. The lectures have names, the lectures have age, and all those things. So the whole structure of an organization is built by using smaller bricks, smaller components. So the structure of the school is created by the smaller components like unit, department, and so on and so forth. Building upon the smaller structures, we build the mega one. So that is like the structural pattern that we will be using. And the next thing is the behavior patterns. It take care of the effective communication and assignment of responsibilities between objects. So It's basically how we're going to handle the objects after we created those things. So what sort of things that it should happen when we do a behavior. If you change something in the object, what should happen? Okay, if you execute some method, what should happen? So the behavior patterns, um, its responsibilities is to have the latest state, latest changes delivered to you. Okay, so we have these three design patterns classifications, or what we call built, at least built on their purpose or intent. Of course, there are other classifications, but most commonly that we can see when we are talking about design patterns is these creational patterns, how we create objects, and the structural patterns, how we create more complex, and how we create more larger structures, assembling, how do we structure those things. And the next thing is the behavior patterns, how we gonna act upon these things, how the behavior change will affect on changing some certain attributes, and what are the responsibilities. Most probably what we call these things as state, how the state's gonna change based on uh, our use cases. Okay, uh, so these things we will learn one by one. We will learn some creational patterns, structural patterns, behavior patterns. Then you will guys be able to work as um, work or have some code example and see it in action. So far, any questions, guys? If you have anything, just let me know in the chat, or just raise your hand. I can clearly see what's in the Zoom chat or the participant list. So if you have anything, just disturb me at any time. Okay. The next thing that we'll be using is the having these different patterns in categories. Yes, we talk about the creational, structural, and behavior patterns. We'll be looking into each of these and how we can create these design patterns in real time and the use cases. So by the way, one of the most common questions if you are into software engineering, most of the organizations, big organizations, um, especially with the people who are joining as fresh graduates, one of the most common questions that I got is about, do you know any design patterns? Can you explain one design pattern for me? This kind of question is pretty much normal, almost out of like 90% of the time that I have seen. Most of the guys, the senior guys, would like to know how you gonna manage your objects, how you gonna manage your application, uh, how do you what is your thought in process on these design patterns is tested. So make sure you guys know at least few of these design patterns. You don't need to know all the 23 patterns or 25 patterns, at least most common ones, and we will create these patterns one by one. Okay, so these are the provided various object creation mechanisms which increase the flexibility and reuse of existing code. So we will see the factory method, abstract factory method, builder, and singletons, and see how we can use these patterns within our application. So we have these structural patterns, the adapter pattern, the bridge, composite, decorators, facade. This one is a little bit tricky, but yeah, it is mostly used in web applications. So proxy, flyweight, we will look in each and every as much as possible. Then we will see what sort of things that we can do. So most probably we will be looking at the observable pattern and state patterns. These are like most commonly used one at least in terms of software development. So think we looked at the observable pattern last time, observability, using that, and we have used the state patterns. I'm not sure. No, we haven't used state pattern, but let's see it in action. What it explains. Of course, the mediator pattern. Mediator pattern is one of the known patterns out there as well. So we'll look into the most common ones, most at least used one, at least we have seen so far, and we will try to get more out of this. So let's go first with the most simplest form of creational patterns, which is the singleton pattern. Okay, we'll go with singleton pattern, and we will move into factory and abstract factory. So let's see what is singleton. So by using a singleton pattern, as the name suggests, the intent, okay, as you guys can remember, in a pattern, we have defined what is the intent, what is we are trying to resolve from using the these kind of application. What is the purpose? Okay, so the intent of the singleton pattern is described as follows. So singleton is a creational design pattern that lets you ensure that a class has only one instance while providing global access point to this instance. So in a sense, in a singleton pattern, what we are trying to achieve is have one single creation, one single instance. So whenever somebody is asking for an instance, it's not gonna create a new instance for you. It's gonna give one single instance. Everybody has to share that instance and use that. So in singleton creation pattern, it's provide a global access to one single class. So for we'll see this in action. So you guys can see in the image as it's described. So we have this object, but all of these objects, no matter how from where you're gonna access, it's gonna proxy to, or it's gonna use one single object to cater that role. Okay, there won't be a clone, there won't be a copy, only one instance. That instance is gonna be used. Okay, so let's see why do we need this? Why do we need one single instance for this? What is the problem that we are trying to solve? The singleton pattern solves two problems at the same time, violating the single responsibility risk principle. So it has the what do you call, the problems and solves. Okay, let's see in the section. So the first thing that is singleton pattern is going to solve is ensure that class has one single instance. Of course, the name is one single instance. Why do we need one single instance? Okay, so what makes sure that one single instance is what we need? So so ensuring one single instance is suitable for different occasions. Okay, why would anyone want to control so many instances of a class has? The most common reason of the control the access to shared resources, for example, a database or a file. So the main reason that we need a singleton is that the scarcity of the resources. Okay, so for example, within our application, when we are developing web or mobile applications, we'll be having shared resources. Okay, we will have a shared resources. For example, a file or a database. When we are trying to insert something, when we are trying to insert some data to the database, that can be happen by two instances, two places at the same time. Okay, so for example, let's say for example, we have a mobile application. Within that mobile application, uh, we have a place where we can insert the user details. So in our user interface, we will be inserting user information. So the first things that we will include, that will be the username, email, and address, such thing. At the same time, we might need to insert some user permissions like roles and everything. So uh, we need to insert roles for that user at the same time. So we are accessing one single database, one single resource from two different locations. So in a sense, we will be executing some queries. We'll be executing some insert queries against this database. So we'll be inserting users to this table, and we will be inserting some roles to that table. So these two actions will be executed in the same place. Uh, so uh, so uh, so what will happen is, when we want to access the database, for the insertion of users, we get a link for the database connectivity. Okay, first what we need to do is, database, most of the time within application, database reside not within the application itself, even though it is file based or socket based. The database will be running somewhere else, and our application will be running on somewhere else. So what we need to do is, we need to make a connection between the application and the database. So when we are doing that, we provide the username and passwords and everything. And once we have done the connection, uh, we can insert queries. We can execute insert queries, and the data will be sent there. So we can execute queries within the user perspective. And as the user inserts some data, what we will do is, we will send the information to the database. And the second time that we want to insert something, let's say we want to insert the role details right now. Again, what we need to do is, we need to make sure we have a connectivity to the database, and the connectivity is active, and we can execute queries on that. Okay, so these two instances, what we need in common was the database connectivity. The database connectivity is something that we needed. So the common factor in this scenario, inserting two different queries. The common factor was database. The common factor at the end was the database. And in order to put some data in the database, we need the database connection. Okay, so we can achieve this in two ways. The first thing is, when we are inserting the user, we create a database connection. I will call that for now connection A. Okay, so the connection A is there when we are executing a query and inserting a user into the database. The next thing that we are trying to execute, inserting some role to the database. So in this scenario, I am using the connectivity B, in order to do that process. So these two processes have two instances of our database connectivity. One is connectivity A, which is used by inserting user. Connectivity B is used to insert roles. The problem arises, let's say there is two connectivity available. Okay, the problem arises when we have multiple inserts, when we do multiple inserts, multiple tables. So each and every time when we are trying to execute something, if we are creating a database connection, at the end, what will happen is, we will have a lot of database connectivity happening to the database first thing. Okay, and remember, when we are accessing the database, there are certain limits certain session a database can handle. The database is not a place where you can have 1,000 database connection and it works. No, it's not like that. A database connectivity is having certain limits. That is by purpose. The main reason behind that, concurrent access by the same application. If you are trying to reach the same database over and over again, and when we are concurrently we are trying to execute database queries from different applications, the database can get corrupt. Okay, the first reason is that, and the resource that it needs to maintain between the connectivity is high. Okay, so one application has its own connection, the second application has its own connection, that is fine. But within the same application, same time they are having like 6 or 7 database connectivity. That is one of the resources, not in the resource utilization. So in order to avoid such a scenario, what we will do is we don't create a database connectivity each and every time. We have a one single database connectivity and we reuse it each and every time. Okay, so for example, when we are trying to insert the user, okay, let's initially think there is no database connectivity. Then what we'll do is we will create one single database connectivity. And when the user insertion is done, the database, rather than destroying that database connectivity, we reuse that. We use the same database connectivity for upcoming database activities. So when roles table is trying to insert something, we don't create a new database connectivity. We just reuse the existing database connectivity and insert that. The main problem it's trying to resolve is the resource scarcity. These kind of reusages will improve what we call the resources that we use. So we don't have that keep in mind the fact that creating a database connectivity is comparatively memory intensive task. Okay, rather than we creating a lot of connection at each and every time, we create one and we will have one single instance, and that single instance, if it is work for each and every upcoming situations, then we are saving a lot of resources. So we have the database connectivity and we will reuse that. Okay, so let's take a real world example. Here, imagine that you create an object, okay, but after a while you decide to create a new one. You created object and again you created a new object. Instead of receiving fresh object, instead of creating a fresh object, you will get one you have already created. Note that behavior is impossible to implement with a regular constructor, since the constructor must call always return a new object by design. So, what will happen is, rather than when we are creating a new object, okay, maybe we created an object, later on we need another object. The situation that I mentioned is the insertion of user and role detail. So when we are inserting user, we need a database connectivity. When we are inserting roles, we need another database connectivity. Rather than creating a new one, what if we use the same old one, same old database connectivity that we have, and we can use that. So creating such a singleton in a constructor is not possible. Okay, when we are calling the constructor, it's always going to create, it's always going to return a new object. That is the basic behavior. So for example, in Java, when we are creating a new object, we assign the keyword new and we pass everything and it will give us the created object. Okay, again we want to create something else. It will create a new object and give us the same thing. So conventional constructors, if we call the constructor 2 times, that means 2 objects are created. So conventional constructors cannot implement a singleton. So the design patterns, okay, the design pattern is trying to solve this problem. Okay, so the conventional constructor can't give us a singleton by its design. That is the flaw. So we need to create an instance in a way, so we can have always the same object for it. So as I mentioned, it goes for the file accesses as well. So if you are trying to access a file, remember file access. If you are trying to access the file on different places, the file might get corrupted. So rather than 5 objects competing the same file object, we can have one single object which has the connectivity to the file, and we can reuse that over and over again. Okay, so rather than creating what's you can see that rather than like what we can see it in here. So any resources that we will be using can be used again and again. So it won't waste waste our memory and instances. Okay, so the next thing is that we are trying to solve in the design pattern is provide a global access point to this instance. Remember those global variables that you have, okay, used to store some essential objects. While they are very hard, they are also very unsafe, since the code can potentially override content of those variables and crash them. Okay, so for example, we can have global variables. In most of the languages, we have the accessibility to the global access point. So we have these things like in Java, we have some things like static variables, if you guys can remember. So anytime if somebody comes in, they can manipulate the static variable, and the created object is not going to be working as intended. So we need to make sure once we create the global object, once we create the singleton, that is not modified by anyone. It is going to be the same object until the program execution ends. Okay, so just like global variables, the singleton pattern lets you to access same object from anywhere in the program. However, it is protected that the instance from being overridden by other codes. Okay, so in a place where you have all your data, your application, in a singleton, we keep these things in one single global space, but we are making sure that anyone else in the program is not being able to modify these things. Like global variables, you can modify, but we are not allowing to change anything within the singleton that we will be creating. There are another side of this problem. You don't want the code to solve the problem number one. The scattered all over the program. It's much better to have within one single class, especially one of the rest of you already have depending on. Okay, so the problem is like when we are creating new objects, it's gonna scatter all around the programs. Okay, we don't know which one to use at the end. But if you have one singleton instance, you don't have to worry about it. It's the one that everyone is talking about. It is the same design pattern that we'll be using right now. So the singleton pattern has its pros and cons. The singleton pattern has become popular that people may sometimes call it singleton, even if it's just solve the listed problem. So singleton is like is used everywhere. we will see we have used it actually within our NT architecture, but we did not know that is a singleton. Let's revisit that and see how we utilize the singleton in that case. Okay, so singleton pattern is most popular instance creation or the structural creation patterns available out there. However, uh, there is, like, as I mentioned, there are situations where people do not like the singleton pattern on some occasion, especially when it is coming to testing. So when we are testing something, since there is going to be only one global instance of it, okay, when we write test cases like unit test or something like concurrently running on each other, uh, singleton is what we call is a pain to handle. Okay, so the main reason behind that, once we can run unit test and all those things in what we call a parallel manner. So when we are running the code in parallel methods, so the singleton pattern, the singleton object might not be uh, as we expected. So it is uh, sometimes it's giving troubles when we are creating these instances. Okay, let's see those things in action right now. Remember the singleton, what's the problem is all about. Okay, let's see the solution. All implementation of single have these two step in common. So as I mentioned earlier, um, in design patterns, you might not get what we call the code examples in patterns. You will see these are the steps. These are the blueprint that you need to create, and in your programming language, you have in your application. Sorry, whatever the options that you have using those things, please uh, follow this instruction and create one by yourself. Okay, so it's going to give us the instruction, the blueprint. The implementation is up to the user. How you're going to use it, it is up to you. So what we will do is we will look at the instruction, common instruction. What is the solution? How we can create a singleton by using these instructions, the blueprints that it is trying to give us. So make a default constructor private and prevent other objects from using the new operator with singleton class. So the first thing that we need to do is we need to make sure the constructor is private. Okay, once we make the constructor private, that means other objects or other places, we can't create an object out of it. So anyone else who are trying to create an object will fail because the constructor is private. That means the constructor is only accessible within the class itself. So anyone else you guys know that private, when we are making things in fields and functions and even constructors in private, but only within the class we can have the access to it. So if you make the public constructor, the default constructor private, what will happen if you override the default constructor and make it private? What will happen is we won't be able to create new instance. So that is the first thing that we need to make sure. When we are creating a singleton, we make the class constructor private. Okay, so the new keyword is useless once we do that. And the next thing is create a static creation method that can acts as a constructor. Under the hood, this method is calling the private constructor to create an object and save it is in a static field. All allowing calls to the method return the cached object. Okay, so the next thing that we need to make sure that we are doing is we create a static method. We create a static method. So as you guys know, in most of the programming languages, static methods are class bounded. That means only the class itself have the access in static method, you will be able to access by using only the class itself, but not by the object. Okay, the static methods are bounded to the class, not to the object. So when we create a static method, and within that static method, we call our private constructor. We have the private constructor. So what we need to do is we make sure that the private constructor is called within that static method. And we have also this under the hood, the private constructor create an object as well. So it's create an object of itself. The static method will create an object of itself. So, and it will be saved in a static field as well. Okay, so it will be static field as well. So it most of the time it is considered private as well. So when we are invoking the static method, what it will do is, first thing, it calls the private constructor and create the object and store it in a static field. And when that is the first time, and it will return. If somebody is again asking for the same object, what we have to do is they need to access this using the static method. But all the concurrent calls will not call the constructor itself. It will return the created method that is in the static field. It will check whether the static field is null. If it is null, it will create. If not, it will return the created object. So by using this static method, that's the only way that we can access the singleton out of that. So by preventing the default constructor, nobody else can create objects, as well as the default constructor will the static method will call these things, call the objects, and what they will do is they will give back one single object at every time. Okay, so if your code has access to singleton class, then it's always singleton static method. So whenever your method is called, the same object is always returned. So whenever, since this is a static method and the static method is returning the same object, it will be a singleton. So we will see this in action, but remember the what you call the common step or the implementation of the singleton pattern. Make sure the default constructor is private. The second thing is we need to create the static method. This static method called the private constructor. Once the private constructor is created and new object is created, we save it in a static field. All the concurrent access to the object, what it will do is it will create this, it will call this constructor and return the same object. So it won't create new object. It actually can't create any objects because of the private constructor. Once the constructor is private, you can't create any new objects. So the real world analogy. So let's see it's in real world so we can understand what are the use cases of this approach. The government is an excellent example of singleton pattern. A country can have only one official government. Yes, that is true. Regardless of the personal identities of individual who form governments, the title, the government of X, is global point of access that identify the group of people in charge. Yes, that you guys can see that it is it is like the government. It is whenever who is accessing it, we have only one government at that point. So it's not going to be the country can have two governments. I'm not sure with the history as that kind of thing, but in a normal day, we don't have two governments. We have one single government that is governing everything. So regardless, if I go and access the services and someone else go and access the service, it's going to be the same government acting upon us. Okay. So let's go to the structure. Let's go to the structure and see how this is represented in a class diagram. So I hope you guys have learned class diagrams. The implementation is pretty much simple in the Singleton pattern. So you guys can see that in the class itself, it has three sections: the class name, fields, and the methods. So we name our class as Singleton. Okay, so we have a class called Singleton. And what we need to do is the Singleton instance. We have a variable or field called instance, and it is going to be the same type of the class itself. So we have a variable called instance, and it is Singleton. As you guys can see, the minus sign, it represents that is private. Okay, in class diagram, if we have something in minus, that means it is private, that is only accessible within the class itself. So this instance, there's a field called instance, and that instance data type is going to be the same as the class type. Okay, so we have this instance, and we have this constructor. This is the constructor that we are having, and you guys can see we need to make sure the constructor, the default constructor, is also private, so no one else can create any object from that. So the default constructor is private, and we, as you guys can remember, we need to make sure these two are statics. Correct me if I'm wrong. If it is static, we underline this one. Pretty much sure that is the use case of the class diagram, but can't remember exactly. I will get back to you on that. But if it is static, we have underline on this. That's why this underline is there and not in the Singleton constructor. Of course, constructor cannot be a static one. And the next thing is we have this method. You guys can remember, create a static creation method. So most of the time, what we call, what we have is this method called get instance. Okay, we use the same name for convenience, so everyone knows. If this is a singleton, okay, we can get the singleton by calling get instance method. Okay, this is a static variable, and it returns the singleton. Okay, it's returned a singleton that is the same as its class. So it is public, otherwise we don't have any access to the created objects. Okay, and remember, this is while we can make this instance field public, that is not the recommended way, that is not the step, that is not how we create what you call a singleton. We need to make sure we are accessing that that is by using this singleton method. The reason that we can't even do that, because when we are making this private, there is no way to instantiate this instance unless we call it in the constructor itself. Okay, that is there is no way that we can call the private constructor unless we have this method. Okay, so we have a public static method. The public is denoted by this plus sign, static is denoted by this underline, and it's going to return a singleton, and the method name, the function name of the method name itself is what we call a get instance. This is going to be a static one. Okay, So we have completed all the requirement for being a singleton. Make sure the default constructor is private and have what do you call what we call the static method to get the instance, and that get instance method should access one of the existing static methods, and it will return the same type, the singleton type that we are working with. Okay. So if you look at the implementation, implementation for this gets instance method, it's going to be pretty simple. If the instance is equal null, that means we have not instantiate instance in here. So the instance, the first time that we are trying to access, it will check whether it is null. If it is null, that means we have not initiated a singleton. So if it is null, we will create a new instance and assign it from the method itself. As you guys can see, as you can see, the instance is created in here, and the new singleton, this is the private constructor that we have already written. The private constructor will be only the place that we can create it. That means the first time it will create a singleton instance and have it stored in the static variable name instance. And once it is done, it will return the instance. So the next time when next time someone in the program want to access this singleton, what will happen is the instance is not going to be null. That means we are not creating a new one, but we are returning what we have already within our graphs. So we'll be returning the created singleton in here. The singleton class declare a static method as get instance. There is like the norm that we use, get instance. Okay, you can have any other name, but remember, most of the time when we are running with these things, we need to make sure that we are using the things most of us is using. So we are creating the get instance method. It returns one, and it returns the same. So it's returned the same type as its creation. Okay, so the singleton is the class itself, and we are returning a new singleton as it is. We are not creating anything else. We are creating the same type, and we are returning that. The singleton constructor should be hidden from the client code. Calling get instance method should be the only way that getting the singleton object. Okay, that is true. The client code who is trying to access this class should only be working with the get instance method, and the other way is not going to be possible. That means other than calling the get instance, you won't be able to get an instance out of it. Okay, all right. Anything else? Anything you guys did not understood in this scenario? Okay, oops, everything is in order. And one other thing that is one other thing that we need to make sure, this client's code, that when we are creating this singleton instance, say for instance, the creational section, when we are creating this singleton pattern, when we are creating it for the first time, when we are creating this singleton, there might be a situation where one or more threads are accessing this singleton instance. Okay, so I'm talking about the first time. Okay, So what we are trying to do is when two threads are trying to the client that you see in here, imagine another client in here, and it is trying to access the singleton at the same time. So it can be achieved by using two or more threads. Okay, if you run the client invocation in two threads, this singleton object creation might be attempted by two different threads, and while the first one is instantiating, the second one can call, and they can disrupt the new instance method. Okay, so in a scenario like that, what we have to make sure that if two or more threads are accessing this application, we need to make sure that the instantiation creation process that happened in here is thread safe. Okay, so it's mentioned in here, not if you are creating an app with multi-threading support, you should place the thread lock here. That means two threads are trying to create one singleton that will defeat the purpose of the singleton, that will corrupt it. Sometimes it won't work as expected. So what we need to make sure when we are creating this instance, we need to make sure that if there are multi-threading support is available, two threads are accessing, one block or one thread is blocking the other one's code. That means, let's say we have client A and client B running on two threads, and when client A is accessing, client B is also accessing. But if somebody is working with the client A is working, then at that time, the client B should not get an instance. It should wait until this client A is done with the instantiation, and then the client B should be accessing the instance. So make sure the thread safety is there. So if you are using a programming language like Java, we can use what we call the synchronized blocks. Okay, the synchronized block will make sure that two different instances are not accessing the same time. So if we have two threads, we are making sure that these two threads are not creating two singletons. One singleton, while one singleton is at work, the other one have to wait. The thread block process, the synchronization process should happen at this point. So make sure multi-threading is one of the errors that we can come across. We need to make sure the multi-threading is not happening at the object creation level, at least this at this instance. Okay, so that is something that we need to make sure. So let's look at the pseudocode for this. In this example, database connection class as a singleton. Okay, so the database class is a singleton. The class does not have a public constructor. It should not have a private public constructor. So only way to instantiate that object is call the getInstance method. The method caches the first creation objects and return the subsequent code. Okay, that is the implementation itself. So this is the class that we are making as singleton, and we need to have a private static field. Okay, it's the same instance. We call the name, or we can have the naming to the instance or the creational one as instance, and the type of this instance should be as same as the class we are trying to create. So the database is the class that we are trying to implement. So we have something like that. And make sure the constructor is private when we are creating this singleton. So we have the requirement ready. Instance, it will be a static one. Constructor, it will be a private one. And the next one is that we're going to be using the getInstance method. Okay, and make sure that is public. Okay, because otherwise we do not have an access to the instance because this should be public. The constructor is private. So now what we have to do is we need to get the instance. We call this method. And what we can do is we can check if this is null. Okay, this field is null. You don't have to call this database.instance, but you can since it is a static method. And if it is null, then what we have to do is we need to acquire a thread lock. Okay, that's what I mean by if this process is going to happen by one or more threads, that we need to lock it first. Otherwise, two different entities trying to access the same thing, it will defeat the purpose of Singleton. So what we need to do is we need to acquire the thread lock. In Java, we can use the synchronous keyword. Other languages have the same discipline. We'll see that in action right now. For right now, we will say we will acquire the thread lock. And next thing that we need to check if the database is null, this instance, if it is null, we need to create the database instance. It's going to be the same type, and we have assigned that value since it is the first creation. And when we want to have the instance, we will return that instance as it's supposed to be. So we will be returning that instance when we call that again. For the first time, what will happen is it's going to acquire a thread and instantiate. I'm thinking of now this is like a waste at this point because this is already null. So I don't think we need to make sure that is again a null check because we have already done it. That's why we are in the call. That's why we are in the acquired thread and in the same situation right now. But anyhow, this is a pseudocode. Your implementation might be different. And we can have other methods like executing queries and everything. That is totally fine. But anytime anyone needs a database connection, they can't create a new database connection. They can only create the existing. What they can do is only use an existing connection and reuse it for other purposes. Okay, so we can have other methods where you can execute queries and everything that happens as normal. So you guys can see when we want a database instance, we do not create a new keyword. Instead of that, we use the static method that we have created, database instance. So we have instance of the database because the instance that we are creating is going to be the same instance that we are working with. That means it's going to be a database in this scenario. That's why it is the type for the foo is database. Then once foo is executed, once the foo is initialized, first time it will create one, and it will store it in the field called instance within the database itself. And the concurrent call, if you call the get instance, what will happen? It is going to give the same one that we have used for this method call. It will return that, even though the name is bar, it's going to be the foo that we are working with. And bar.query will execute any query that you are trying to execute, and it will work as such. So the instance that we are talking in here are going to be the same. First time it will create one, the second time it will return the created one. So that is the basic concept of the Singleton application creation. Okay, so let's see in action where we can apply the Singleton pattern. Use Singleton pattern when a class with your program should have just single instance available for all clients. Of course, For example, a single database object shared by different part of the program. Okay, so in different part of the program, as I mentioned earlier, do not create database connection on your own. That is considered what we call reckless behavior. Of course, there are programs that we can see to avoid such scenarios. They use something called database connection pool. Okay, but it is what we call in a case like database connection pooling. That is something we need to make sure we handle those connections properly. But in a scenario like in here, think the database connection is the only one object that we need, and we need to make sure we reuse it once again. So we have the database connection implemented and reusing in the application itself. Okay, so this is most common. This you will see this common pattern in Android and iOS applications. Why? Because you guys can see that we can't have multiple database connection on a single application. And the reason behind that, the resource it takes to create a database connection is high. So rather than creating thousands of what do you call database connection, we create one single and it works. Okay. And it is disabling creating other objects creations. We don't have other methods to create objects. Only through the get instance method we can create an object. If you try to use new keywords, and those things won't work. So we have a way of creating objects and making its only use. It's going to be it's going to change your design, change the way that you think about object as well. So when you are using Singleton, make sure you need what do you call strict variables in your application that you need to create the Singleton pattern. So if you have something like strict pattern, that's one instance going to be there, then you have to use that in order to control the damage if you create multiple objects. Okay. Unlike so what is the construct what is the advantage of using singleton pattern rather than a global variable? Unlike global variables, the singleton pattern guarantees that there is just one instance of the class. Nothing except for the singleton class itself can be replaced the cache instance. Okay, so we make sure that there won't be any other instances. We make sure that in singleton there's only one at the end. Global variables that can be changed, but in a singleton pattern you can't change that. Note that you can adjust the limitation, allowing getting more numbers of singleton instance. The only piece of code that you need to change in the body is get instance method. Okay, so in here there's a special note. You can always adjust the limitation of allowing creating new numbers of singleton instance. For instance, if you say, for instance, as I mentioned earlier, the connection pool kind of thing. So we can have multiple instance of the singleton, but it's going to return one single object, but it defies the singleton pattern. You should always return one single to avoid confusion. But in a scenario like database connection pools, like if one single instance is in use, other ones might get blocked. To avoid that, we can have multiple instances, but it defies the purpose or the device, the usage of the application. So make sure we do not tamper with the actual implementation. Stick to what Singleton stands for. Okay. So implementation we have seen. So let's see the pros and cons. Okay, that is the most important thing when you are using such a pattern. Why it is good and why it is bad. So where it is good, where it is bad. So the pros that you will see in here, you can be sure a class has one only single instance. Yes. So we know since the private constructor is there, no, there is no way we can instantiate the class only by get instance method and implementation. You will be able to do that. You gain global access point to your that instance. Yes, you have a global access point. That means you don't have you have one single instance throughout the application. So if you're familiar with web development or something like mobile application development, in mobile development application, the database connectivity, that is a singleton. In web and mobile, in web development, if you guys know React, Angular, something like that, there is this concept called state management, which is handling all the application state in one single global scope. So that state is also going to be what we call a singleton. That means through the application, we have one single instance to manage it all. So we have the global object at our disposal. We can have the things in that global instance, so it is working and no mutations are going to happen. The singleton object is initialized only when it is requested for the first time. Okay, so the next thing in here, what we call this as a lazy initialization. It is not an eager initialization. That means whenever the singleton object is needed, we need to call the get instance method only when that get instance method is created, we get a new singleton instance. We do not get an eager one, we get a lazy one. That means whenever we are trying to access the instance of a singleton, we are getting one created freshly on that. But there are situations, there are patterns, there are implementation. You will see it won't be a lazy initialization. It will be something like eager initialization. But most of the time, you will see the lazy initialization much more suitable. As we goes, we are not allocating any objects anyway, allocating any memory while we are not using this singleton. Only when we are trying to access this singleton, it creates a new instance. Okay. And yeah, the cons. What are the issues with this pattern? Violate the single responsibility principle. The pattern solve two problems at the same times. So we have what we call single responsibility principle. So that is a violation of single responsibility principle. So we will get into single responsibility when we are talking about clean architecture and everything. Right now, just remember it's violate the single responsibility pattern. So it's a con if you are using single responsibility principles. The problem solves two problems at the same time. That is the reason of the single responsibility principle violation. So in a nutshell, what single responsibility principle means is a class should do only one thing. Okay, the class should focus on only one thing that they need to solve. But the what we call in the singleton, it's doing two. The singleton pattern solves two problems at the same time. So that is not good. So you guys can see that in the problem definition, we have two problems. Ensure that one class has one single instance. This is getting this problem is getting solved, and provide a global access point to that instance. That means we have one single global instance for that instance access point. So it try to solve the first one and the second one as well. So by providing solution, the single responsibility is violated. Single responsibility violation can be uh, something like this object itself is it's gonna be acting in two different manners, two different ways. So unexpected behavior can come when the single object or single class is acting in two different places. So that's why single responsibility principle is important. We have the unpredictability when there are two problems are solved. Okay, so at one time we can think okay, there's a one instance getting. At the next time what we can do is what we can think is the global variable issues. So given the situation, we can't say it's having one single responsibility, it is doing two. So that is violation. But if you are not going against the single responsibility usage within your app, you are safe. But that's a con if you are trying to use it. Okay, the next one, the singleton pattern can mask bad design. For instance, when components of the program know too much about each other. So the next thing is when you are creating the singleton, we do not know what sort of things is instantiated within the instance itself. So since the creation is happening on the instance itself, and the other clients, when they do not have access to that, what will happen is the singleton pattern will have can do whatever they want within that private constructor. The private constructor is creating node, and the static method is creating the instance. We can put anything in our code that will hide this complexity. But if external client is accessing, then they have the ability to access these things. What will happen is we can have the corresponding changes. So okay, we have the full control what's going on in the singleton pattern. So bad behavior can be implemented in the get instance method. So that is not good. Sometimes we do not have the full control over it. So the next thing that we need to focus on, the pattern requires a special treatment in the multi-threaded environment. So the multi-threaded environment won't create a single object at several times. Yes, that is true. So as you guys can remember, there is this acquire a thread lock. That means if you're using the design pattern, the singleton pattern in a multi-threaded application, we need to make sure the thread acquisition, the thread lock is in place. Otherwise, we won't be able to use that. The next con, which is like when you are creating a singleton pattern, it may be difficult to unit test in the client code of the singleton because of the many test firms rely on inheritance on producing mock objects. Since the construct of the singleton class is private and overrides static methods, it is impossible for most languages you will need to think a creative way to mock the singleton, or just don't write test or don't use singleton patterns. That's what I mentioned earlier on. So uh, when we are testing our codes, when we are testing, when we are writing unit test in our code, we normally uh, do something called mocking. Okay, mocking objects. So mocking object is, put it in a nutshell. Uh, rather than implementing the application, the class itself, we have a dummy one created for us. Okay, so for example, uh, let's say we want to test another class. That class is depending on our database class. Okay, say for example, we are developing a web application. The web application have a service, and the service is using this database. So in order to test the service, we need the database, right? We rely on the database calls. We rely on the database connection. So in order to test the service, we need the database. But on most unit testing platforms, what we do is, in order to test the service, we are testing the service, but we do not need the actual database to test that. The service is all about handling the logics within the application. So what we need to do is, we do not need to test the database itself. If we are interested in testing the service, we are going to be testing the service only. Database is, yes, it is a requirement. It is a dependency for that service, but we can't use the actual implementation on some occasion. On some occasions, okay. So in a scenario where we can't use the actual database instance, what we do is, we do something tricky. We mock it. Okay, the mocking process is something like, it is acting like a database. So the service is depending on the database, rather than creating the original database itself. What we will do is, we will create a mock of it. Uh, we will create an alternative version of it, which is having all the methods that the database class is having. So we have mocking frameworks. Okay, so the mocking framework, we should say, mock this database call. What it will do is, it will have these methods and constructors and everything, and look at it, and it will create a dummy object for that. That's what we call a mock. It is not the actual implementation, but it is something we act like the database. Okay, so that's what we call a mock. So we need to mock that object in order to create a mock out of it. Okay, so when we are mocking someone, we need to make sure we know how it is handled. Say for instance, in real life, if you want to mimic someone, if you want to mock someone, what we need to know is, sorry, we need to know how the person is laughing, how the person is talking. By looking at those things, we can mimic a person. I can't mimic a person who I don't know, I can't see, or I can't see an interaction. So that same theory goes in the mocking frameworks. So in order to mock something in OOP world, we need the constructors, we need the inheritance and everything. But since we can't have the public we can't have the default constructor. Without the default constructor, we do not know how we can mock it. We don't know how to create an instance of itself, because the creation part is private now. We can't create a instance out of it. So what will happen is, we are having a lot of troubles when we are mocking the object. So that is one big problem. when we are trying with the singleton pattern, the mocking is making the mocking the object from on certain frameworks is getting harder and harder. So most of the time, testers do not like these private these singletons. It is we have to find alternative ways to create mock objects. So in a scenario like that, singleton is not shining at all. So either we have to say, okay, you are using a singleton. When you are using a singleton, we can't mock that object. So we do not write test on singletons. Or what we can do is we can say, do not use a singleton. We have we need this we need this to be tested thoroughly. So don't use a singleton in this scenario. So this is one thing that we need to make sure what are the pros, what are the cons, and why it is good and why it is bad. The implementation, the pseudocode, make sure you guys remember these things. Okay, it's a simple thing. At least having the section at least having the database initialization up to the get instance method, that is enough. The usage is not important. This is like optional code. Okay, so make sure, even though this looks like there is a lot, most of the time there are comments. So make sure, once the comment lines are gone, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, or at least most of the time 10 lines of codes. Okay, so make sure we have like 10 lines of code. Remember the concept, not the implementation. So once you have the concept, it is easy to implement it in any code or pseudocode. That is the way that we should think about writing the applications. Okay, next thing is other relations to other patterns. We will look in more once we discuss with others. But if you're interested in we can have these all these things. What are the relations? A facade is can transform into a singleton, since the single facade object is sufficient in most cases, because we need to look at facade, we need to flyweight, and we need to look at abstract factories, builders, and prototypes in order to understand what is the relationship. Right now, you will find the code implementation. I'm not sure whether, let me check. Singleton in Java. So these are like the examples that you will see in Singleton. So there are like multi-threaded version, how we can use the multi-threaded version, and how we can protect ourselves in here, and thread safe singleton with lazy loading, how we can do lazy loading stuff in here as well. And so this is like the most common way of finding what we call singleton. So we have a package that is like the normal where we put our code, and we have a public final class, a singleton. By making it final, that means we can't extend even this. This is the final class, so there will be no children implementing this one as well. So we have the final class. We call that class singleton, and we have the private static volatile singleton instance. Okay, so the volatile is making the volatile keyword, making it is thread safe. And we have the instance, we have the variable called instance that is going to be the same type as the class itself. Okay, and we do not need these things right now, but the only thing that we need to remember, the constructor, the default constructor should be private. Okay, and we have the static method which will return the same type as the class. Yes, correct. And the method is going to be get instance, and we can pass any string if we have. And what we can do is we can check the result. We can just simply check in the instance itself. If it is not null, then what we are doing is we are returning that. That means it's already has happened. It's already has instantiated. So we do not need to create it. The result in here, the instance is already done. So what we have to do is we have to return it. So the second time that you are coming into the application, it will return the already created option. And the next thing is that we need to do is obtain the thread safety that is done by this synchronized keyword. So by using the synchronized keyword, and we have to define where the synchronization should happen, we are within the singleton class itself. So if multi-threaded, for some reason, if the multi-threaded application is coming in here, it is thread safe. The thread safety is on. So nobody else or anyone else who are trying to access this thread will be blocked. So only one instance will be created at a multi-threaded application as well. And the next thing that we need to do, if the instance is null, if the instance is already null at this point, what will happen is we will create a new instance, okay, by using the private constructor. If it is have values, we should pass those things as well. And once it is done, we will return the instance. That means the thread safety is there in here. So multi-threaded demo, you guys can run this out and check whether it is working as expected. There are more examples. This is only on Java. So if you have experience in TypeScript, you guys can go with that. And if you want Python, you guys can read the Python itself. The implementation is going to be something similar in here. So you guys can see the implementations has been done in here. And that is this is the singleton implementation, but you guys can see the semantics and everything is changing. And the thread safety is not implemented in here as well because of the nature of the Python itself. And we are creating a singleton main X application by doing this simple business logic call. Okay, so different languages, so whatever the language that you are familiar with, just have a look around it. The syntax changes, as you can see, but remember the blueprint, the way that we are working with the singleton is going to remain the same. So you can have other languages like TypeScript or JavaScript, how we are making this happen. So TypeScript one you will find much similar to Java one. So you don't have to worry about that much. Okay, so we talked about the singleton pattern. Anyone have any questions on singleton pattern? Okay. All right. So what we will do is we will move on to the next design pattern. So we will use the factory method. It's like the counterpart of singleton. Okay, so what is the intent? What is the intent of the this design pattern? Factory method is a creational design patterns that provide an interface to creating object in a superclass, but allow subclass to alter the types of the type of that it will be created. So in factory method, you guys can see that it is creating instances. Okay, it is creating instances, but the superclass is going to be the same, but subclasses, what are the implementations of its subclasses, it's gonna allow it to change. So take a good look at this picture itself. So we have things like logistics. Okay, so the logistic is a common thing that we can have the common way of defining some uh, uh, logistic is like common way of handling stuff. So this company is handling logistic, but this is the base, and the logistic can take two forms: road logistics and sea logistics. So even though the implementation of the logistic is same, the subclasses, the road and sea, they have different outputs. In here you guys can see road logistic will have things needed, will be things needed will be gone what do you call, delivered through trucks. In sea logistics, you can't put a truck on sea, so but in sea logistics you will use a boat. Okay, so the logistic is like the common norm. Okay, based on your need, based on your preference, it can be the subtype, the road or the sea. You can choose the implementation as you like. Okay, so the factory method. Okay, the factory method is it's creating objects in a superclass, but allows subclass to alter the type. Okay, basically it is logistic. Other things based on the subclasses, rod OC, it will alter its type. So how we gonna what is the problem that we gonna see? What is the exact problem that I will see in a real world situation? Imagine that you are creating a logistic management application. Okay, first version of your app can only handle transportation by trucks. So you build a code lives inside the truck class. Okay, so we have a logistic company, and the logistic company is running based on what we call trucks. So everything that we need to do, every transportation mechanism and everything that we do is based on this class called truck. So it has everything related to logistic in this truck class. After a while, you have become pretty popular. Each of the day you receive dozen requests from the transportation companies incorporate to sea logistic into it. Now, over time, what will happen is our application is doing good. Now we need to not only get land, but also sea logistics as well. So the logistics that basically in logistic, what happens is we deliver something from point A to point B. In the first version, the good thing is we use land transportation, something like trucks, and when our app is getting more popular, what will happen is we have the sea transportation. So the core is same. The concept that we need to do, the things that we need to do is deliver something from point A to point B. but the medium has changed. The medium is now C. So earlier, if it is something like this, everything in our application is wired to trucks. Okay. Now we get a new requirement, the boards, how we gonna fit in the logistic app with the C transportation. Everything is wired up in a way. It is working in our application with trucks, but we got a new requirement. We got something new that needs to be handled with C. So great news, right? But what about the code? We have expanded our code. We have expanded our business, but the code is the problem. At present, most of your code is coupled with truck. Yes, everything that we know about transportation is known in land transportation, and everything that we have is with the truck. So adding a ship into this app would require making change to the entire code base, of course. So having a ship into this application, either we need to write a separate application, or we need some way to compile this in the ship logistic into this app. Okay, so moreover, if later you decide to add another type of transportation to the app, you will probably need to make all these changes again. Okay, the problem rise again. Okay, we have land transportation, we have sea transportation. Now all of a sudden everything is going good because we have implemented, somehow we have incorporated this one in here. Then again we need to come up with new transportation type, like we are getting plane transportation or aeroplane transportation. So it's going to be a different error. Or we are doing good, we are doing it in a car transportation. It is not going to be the same as truck, but even though it is land, it's going to be a little bit different. And the ship transportation, earlier we did only ships. Then again we got new instance at boats. So when the application grows, the transportation mediums change, the methodology change. So in a situation like that, how we gonna adapt? How we gonna make the behavior changes on that? So as a result, you will end up pretty nasty codes, a little bit conditional if you want to switch the app behavior depending on the class and the transportation object. Yes. So if we put this ship code into our logistic app, we have to say if the transportation is type is C, and we do something else. If the transportation type is land, we need to execute this. There's going to be a switch case or if else held in our application. Okay, so we will end up having a lot of issues when we want to compile with a new type in this solution. So what we can do, what's the solutions that we're going to do? Okay, the factory method pattern suggests that you replace direct object creations calls using new operator. Okay, the factory method suggests that you replace the direct object creation calls. So using new operator, so we can't use the new operator. Okay, let's see how this goes. With the call to special factory method, don't worry, the object still is going to be new operator, but the being called from within the factory method. So rather than creating a new object out of it, we are creating a factory method. Using that factory method, the object is returned. Rather than creating something new, the factory method will have a simple method. That method will give us the object creation. So object returns by the factory methods are often referred as products. So whenever we are calling these factory methods, it's often what we call these things as products. Okay, so we have the factory method, and when we when we create these when we call these factory methods, we get a what we call a product. So let's see this in action. So we have this class called logistics, okay, and this logistic class have plain delivery, okay, that means the delivery information, and create transport method. So these two are public methods, you can see. And the logistic class is inherited. You guys can see the inheritance in the class diagram right now. And one with the road logistic, the other one is with the C logistic. So when we have this when we have the inheritance, the most with the inheritance, what we can do is we can override. Okay, the overriding is available for us. So what we will do is the create transport method we will override within the road logistic and the C logistic. Okay. So let's see the implementation, and we will see how these things will end up. So when we are calling the road logistic, we will get a truck. When we call the C logistic, we will get a ship. So this is like the implementation, and we will see how we gonna make this happen in code wise. So we have the logistic, we have road logistic and C logistic, and remember the logistic class is inherited by read logistic, sorry, road logistic and C logistic, and they are overriding the create transport method, which is in the super class. Okay, at first class, this change may look pointless. We just move the constructor called one part of the program to another. However, consider now you can override the factory method in subclass and change the class of the product being created by the methods. Let's see how it works. There is slight limitation though. The subclasses may return different type of product only if the product have a common base of class or interfaces. Also, the factor method in the base class, you should have the return type declared as it is interface. So the method of transportation, it is not going to be a class, but it is going to be an interface. And the way of the application is delivering is going to be in this interface. Why it is going to be interfaced? Because the truck delivers in a different way. The C is delivered by in different ways, but both of them are delivering. So both of them are doing the deliveries. So they need the interface, they need the method of delivery, but the delivery done by a truck, delivery done by a ship is two different implementations. So in order to do the actual implementation on each, we have to have these common actions in an interface. Okay, we'll see this in action right now. Just have the logics in here in your mind. Okay. For example, both trucks and ship classes should implement the transport interface. Of course, both of them should do the transportation, and the transportation implementation, the way they are doing is going to be different on each. So we can't have a concrete implementation. In order to avoid that, we use interfaces to do that. Okay, we will see this in action, but just have a glimpse of mind in your memory. With the declare method called deliver, each class implement method differently. Trucks deliver cargo by land, ship deliver by sea. The factory method in road logistic class return a truck object, where the factory method in the C logistic will return a ship. That is true. So whenever we are creating a logistic app, now our boundaries are little bit change. So we do transportation at either way, the transportation is happening. So if we use the road logistic factor method, we get a truck. And if you use the sea logistic method, we will get a boat. Okay, so this is how it is like visually shown in a class diagram. So we have the logistic. We if we call the factory method for road logistic, we will get a truck. And if we call the factor method for sea logistic, we will get a boat. So that is obviously no one can mess around the transportation method. But anyhow, both of them are going to be doing the delivery. So we need to have that in an interface, and that interface will deliver. Land delivery implementation is going to be different than the ship one. So those things are going to be doing the same job, delivering, but in a different way. So now we have the code structure like this. Everything is doing a transport, but road logistic will return a truck. Sea logistic will return a what do you call a boat. Okay, let's see the structure of our application. Okay, so we have the first we have the interface of the product. Okay, and that interface is defined in the application application creation. If you guys can see, if you guys can remember, we call what we call object returned by a factory. Often we call as products. So we name this thing as product, so makes things easy. So product have a method called do stuff. Okay, the do stuff is what the product is supposed to do. And this is, remember, this is an interface. So interface has no what we call a concrete class. In order to make this work, we have to have the concrete product A implementing this interface. Okay, the concrete product B should have interface, should implement this interface. So in this scenario, the truck and the ship should interface, should implement the what we call the delivery interface. Okay, and the third part is the logistic app itself. The differentiation, how we're going to create different one, the creator part. And we have this create product. It's going to be either of these products, and we can have some operations bounded to that. And the creator of these things, it is going to create something. This is the product and this is the creator. And the creator will also inherit from the concrete create class. In the concrete create class, you can see the create product, and create product is going to be in here. In both cases, it is overriding this create product in our application. So when we call the create product A, it will return something else, and we will call the create product B, it will give us something different. But at the same time, they will do the same operation on both concrete creators. Okay, so let's look at the implementation. First, the product declares interface, which is common to all objects that can be produced by the creator and its subclass. So since this is interface, each and every creator classes and the concrete classes will have this do stuff method in with them. So concrete products are different implementation of the product interface. So the concrete product A and concrete product B will be two different things, but they will have this do stuff method implemented to them. The creator class declare factory methods, return new project objects. It is important the return type of this method matches the product interface. So when we are calling the create product, it's gonna return a product. And remember, this product is this interface. Okay, this creator will be this product interface. When we are when we are calling the concrete creator class B, we call the create, but it's gonna be a product. So the implementation of A and B are going to be of type this. So it can be either a concrete product A or concrete product B. So it is generic. It is not known for either it is going to be A or B, but it's going to be something of a type of product. And concrete creator. Concrete creator, this is like the base return of the type, and it is gonna give us the mediation, whether it is gonna be giving us a boat or a truck in this scenario. So let's look at the pseudocode, so you guys have a better understanding of what's going on in here. This example illustrates how a factory method can be used to create a cross-platform UI element without coupling the client code and concrete UI classes. So we are creating a factory method for a button. Okay, illustrate the UI button that we're going to be creating. So what we will do in here, we will have a concrete class called dialog. So dialog is a pop-up window that will show. It is not giving any implementation, whether it is going to be running on a Mac operating system, Windows operating system, or a web page. It does not declare what the dialog is going to be. It is going to say, okay, we will define how a dialog should look like. And each and every dialog will have a button that's say on click. That means on the dialog we will have a button, and we will have a render method. Okay, so we have two methods in this button. One is called click, one is called render. So this dialog creator has this create button method, okay, which is in the dialog itself. And remember this button implementation, the create button will return a button. It does not know which type of button is going to be there. Web dialog is also going to call the create button, but it does not know which type because it is an interface. The window button is when we are using a Windows dialog, and HTML button is when we are using the web dialog. Okay, so even though we call this as a button, we do not know the implementation of what it does. It is an implementation of this button itself. When we are using a Windows dialog, we will get a Windows button. When we are using a web dialog, we will get a HTML button. So we have the common scenario of a dialog, and whether it is going to be a window dialog or a web dialog is based on the output that we are interested in. Okay, let's skip the implementation for now, and we will see these in action next time. So we will see the factory pattern in, let's say, in Java, and see how we can create a button like this. It's, I think, the dialog interface is created. Let's see it is in action and see whether we can make something in here. All right. Yeah. So I'll stop for today, and we will continue factory pattern on next lecture. Okay, just have a look around the pseudocode and we will implement this in our upcoming lecture, or we will find something else for fractal pattern implementation. All right. So you guys have any questions that I need to ask before stop the recording? Anything related to the two patterns that we talked today? Okay. I'll stop recording.